All right, today we're pulling back the curtain on something super interesting. We're not getting lost in the weeds of quantum physics itself, but we're looking at something just as cool, the final exam. Think of it as the final boss battle that stands between a student and becoming a full-fledged quantum programmer. So, what do you picture in your head? A crazy hard math test? Some mind-bending essay on quantum theory? Well, the reality is actually way more practical, and honestly, a lot more exciting than that. Every good story has a final challenge, right? Well, for these aspiring quantum programmers, it's a capstone project. This is where they have to prove they can do more than just talk the talk. They actually have to build something real. Yeah, this is no multiple choice test. It's a full-on capstone project where students have to create a real quantum application and submit it to a real platform, IBM Quantum. It's all about proving you have practical, hands-on skills. But of course, you don't just walk into the final battle unprepared. Before this final challenge, the students go through an intense week of assembling their quantum toolkit, really sharpening all their skills for what's ahead. And here's what's in that toolkit. We're talking fluency in Qiskit, that's the key programming language, knowing how to design quantum circuits, how to actually measure and see your results, and even how to tap into real quantum hardware. It's the whole shebang. And what's really wild is the speed of it all. This isn't some slow, semester-long thing. Nope, it's a 7-day sprint. They go from just installing the software to tackling a competitive-style challenge in just 1 week. It's a serious boot camp. But here's a crucial part of the training. It's not just about what these amazing machines can do. It's also about what they can't do, yet. A truly great quantum programmer has to understand the real-world limits of today's noisy, kind of imperfect hardware so they can actually work around those issues to get meaningful results. All right, so their training is complete. Now it's time to choose their destiny. See, students don't all face the exact same exam. Instead, they get to pick from one of 3 different quests to prove they've mastered the material. First up, Mission 1, the Oracle Search. This is all about using something called Grover's algorithm, which is a quantum search that is way, way faster than any regular computer could do to find a specific needle in a haystack. This is a huge deal because it showcases the incredible speed of quantum computing, something that could revolutionize everything from logistics to discovering new medicines. Then you've got Mission 2, the Number Factorizer. For this, they use Shor's algorithm, probably the most famous quantum algorithm out there, to find the prime factors of a number. Now, factoring 15 sounds easy, right? But the same logic, scaled up, is exactly what could one day break most of the encryption we use today. This mission really represents the disruptive power of quantum computing. And finally, Mission 3 is for the creators, the custom builder. This one's completely open-ended. The challenge is to design your own unique quantum circuit from the ground up. This path represents the future, the need to invent brand new tools for problems we haven't even really defined yet. It's all about innovation. So picking a mission is just the beginning. To actually pass, students have to show their work through a pretty formal submission process. It's not just about getting the right answer. It's about being able to clearly explain how you got there. The submission is basically a 3-part package. You've got the code itself, which has to be clean and well explained. Then there's a README file, which is kind of like the instruction manual. And finally, the proof, a clear visual of the results, like a histogram, that shows your experiment actually worked. And get this, the grading isn't just done by a professor. It's a peer review process. The students actually evaluate each other's work based on things like correctness, how clear the code is, how efficient the circuit is, and even creativity. It's all about preparing them to collaborate in this brand new field. So after all that, the intense training, the final mission, what's the ultimate reward? Well, as you can probably guess, it's a heck of a lot more than just a good grade. This is the real prize. They walk away with their very first complete quantum project, which is a huge deal for their portfolio. But even more than that, they gain the confidence that comes from wrestling with a quantum computer and winning. They've proven to themselves and to the world that they have what it takes to build the future. So these students took theory and made it a reality. They've built their very first quantum projects. Which brings us to the final question, and this one's for you. If you had the keys to a quantum computer right now, what would you build? What problem would you want to solve?